to be here and to talk about how the emerging storage-next paradigm will change the design of future AI infrastructure. So we know that as AI grows, with more and more applications, we'll need this random data access at terabyte or petabyte scale. But we know that for that, the DRAM is too expensive and SSD is too slow. And also, we know this storage class memory really never panned out. But today, the NVIDIA Storage-Next is changing the game. That by pushing the SSD to improve the random rate performance by 10x, and then we can open the door to rethink how the future AI infrastructure will be kind of architected. So first, what is the storage-next? It's actually very simple. It's a very simple concept. It is started by NVIDIA and to redefine the solid-state drive. And it is enabled by two things. It's very simple. One is that we use a GPU instead of CPU to act as the storage engine to unleash the full potential of a NAND flash memory. And the second, we have better NAND and the controller that we can improve the random performance of the SSD by 10 times. And together, they will they allow us to use the flash more like a memory. So how we can best utilize this kind of a new type of storage device? So basically, two things. One is that we have to rethink how we can make the algorithm better take advantage of the very high random errors at small block size. And two, because SSD is much cheaper, so then we should be more willing to waste space if that will make things easier and faster and more efficient. So let me just use two very simple examples to demonstrate what I mean here. First is that we know that approximate nearest neighbor search, ANN, is one of the cornerstone tasks in AI infrastructure. It is not dominated by the random access to all the embedding vectors. So then we can use this storage-next SSD to much better serve this ANN, by using this very simple example, a very simple idea, like a two-stage. So first, we do a very high-speed scan over what we call the reduced resolution vectors, very high speed, leveraging this ultra-high ops. And then we just we use a full vector to refine, and then we can retain both the speed and accuracy. So here, certainly we need to address those two issues. Is very easy to address. That one is that how to get this reduced vector, and we have a wide variety of different options. And two, because the distance calculation becomes approximate, then we need to do distance distance calibration, and that also can be easily done. Our experiment shows that we can improve the ANN search performance by 10 times, and at the same time almost retain the 100% of this ANN search quality. And second example is a key value store. It's very simple. As a future, we can use the storage-next SSD to host both index and the data of the key value store on the SSD. So then we are not limited by DRAM. So then we can. So then here, we use a very simple idea from a cuckoo hashing. Then we can achieve actually for the first time we can enable that fully SSD resident key value store to achieve over 100 million ops per second. And that will fundamentally change many large-scale systems. So finally, the message is very clear that with advent of storage-next SSD, it is changing the software contract. So then we have to switch from DRAM-centric to the SSD-conscious mindset, and then by fundamentally rethink how we design the caching, placement, and algorithm. So thank you very much.